Hi, we meet again for the next lecture 3 out of 4 for chapter 8, Limits and Continuity. So, for today we are going to continue with the next subtopic, which is 8.2, Asymptotes. Okay, so for today's lesson, we are going to focus on the 8.2 part A, which is to find the vertical and horizontal asymptotes. Okay, let us begin with the first part, which is the vertical asymptote. What is the definition of vertical asymptotes? So all we know, we can imagine the vertical is a straight line vertically. Okay, so a line x equal to a is a vertical asymptote of a graph of a function y equal to fx if either limit of fx as x approach to a from the left side is equal to positive infinity or negative infinity, or limit of fx as x approach to a from the right side equal to positive infinity or negative infinity. So if you can see here, means that we want to find infinity limits. So this infinity limits, the value as x approach to is the vertical asymptote. So let's see some example for this vertical asymptote. Find the vertical asymptote of function fx equal to 1 over x squared. So what we want to find is that the limit for this function is equal to positive infinity or negative infinity. But we don't know what is this x approach to. Okay, so how can we find this limit equal to infinity? Yes, we know that 1 or any value over 0 can be interpreted into positive infinity or negative infinity depending on the 0 value in the denominator. It's either positive or negative, right? Okay, so we have to check the denominator. How can the denominator will be 0? Okay, so for this example, for the denominator to be 0 is when x square equal to 0. So what is the x? X approach to 0. So limit of function 1 over x squared as x approach to 0 from the right side is equal to, so if we just substitute the value, it will be equal to 1 over 0 squared. So 1 over 0 squared. So this 0 will be positive because it's from the right side, right? So 1 over 0 from the right side is equal to, yes, we can assume x is equal to the positive infinity. Means that, or we can find from the left side, which is, it will be the same 1 over 0 for the left side, which 0 squared from the left side will be positive also. So it will be positive infinity. Okay, means that from this calculation we can show that line x equal to 0 is the vertical asymptote of function fx. So let's do another 3 examples so that we can understand more about the vertical asymptote. The first one, determine the vertical asymptote for fx equal to x plus 3, x plus 2. As I said from the previous example, for fx to be undefined means that the denominator should be equal to 0. That's why we equate x plus 2 with 0. So the x should be equal to negative 2. Means that we can show that the vertical asymptote is x equal to negative 2. How? To show that the limit of fx as x approach to negative 2 equal to infinity, positive infinity or negative infinity. So let's us find the limit of x plus 3 over x plus 2 x approach to negative 2 from the right side first. So what will be? So it will be negative 2 plus 3 divided with negative 2 plus 2, which is 0. So the 0 is from the right side because it's from the negative 2 from the right side. So what will be? So any value, this is 1 over 0, which is equal to positive infinity. How about from the left side? It will be the same. So thus the line x equal to negative 2 is a vertical asymptote. Okay. Example 2. fx equal to 1 over x squared minus 1. For fx to be undefined, we can assume the denominator equal to 0. So x squared minus 1 equal to 0. So what is x? So factorize x squared minus 1, we get x minus 1 multiplied with x plus 1 equal to 0. Means the value of x is equal to 1 or x equal to negative 1. So we just have to show the limit as x approach these two values equal to negative infinity or positive infinity. So for x equal to negative 1, the limit of fx 1 over x squared minus 1 as x approach to negative 1 from the left side is equal to what? So 1 over 0. So 1 over 0, positive there, it will be positive infinity. For x equal to 1, the limit of fx 1 over x squared minus 1 as x approach to 1 from the right side is equal to 1 over 0. So 1 over 0, positive here. So we get positive infinity. Thus, the line x equal to 1 and x equal to negative 1 are the vertical asymptotes for fx. We get the value and we have to show how we get the value. Okay? So, the next question. Question number 3. As fx equal to 2x over x squared minus x minus 2. So what we will have to do to show that where is the function fx undefined. So for fx undefined, the denominator equal to 0. So x squared minus x minus 2 equal to 0. So we get x minus 2 multiplied with x plus 1 equal to 0. So the x should be 2 and x equal to negative 1. Okay. So please show by using the limits function. Definition. Limits for fx of 2x over x minus 2 x plus 1 as x approach to negative 1 from the right side is equal to 2 multiplied with negative 1 divided with 3 negative 3 multiplied with 0 positive there. Okay, so we get denominator equal to 0, right? So divide with negative 0 from the right side, it will be positive infinity. And then for x equal to 2, the same thing, limit of 2x over x minus 2 x plus 1 as x approach to 2 from the right side equal to 2 multiplied by 2 divided with 0 positive multiplied with 3. So what we get here is 4 over 0 positive. So it will be positive infinity. Thus, this value x equal to negative 1 and x equal to 2 is the other vertical asymptote of fx. Okay, so let's move on for the next part, which is to find the horizontal asymptote, horizontal lines. And then, what is the definition of horizontal asymptote? So let's say a line y equal to b is the horizontal asymptote of the graph of function fx. Then, it means that the limit of fx as x approach to infinity, positive infinity, equal to a fixed value b. Or, the limit of fx as x approach to negative infinity equal to a certain value b. So now, this is actually limits at infinity. Okay. So let's see this graph. So we can see that the graph is going to the left side, moving forward into the value of y equal to 4, but not touching the value of 4 there. Okay. In figure 8.2.1, as x approach to negative infinity, fx approach to value of 4, but never quite reach a value of 4. It's going to 4, but not touching the 4. So using limit notation, we state the limit of fx as x approach to negative infinity. Why negative infinity? Is going to the right of the x-axis equal to 4. It's approaching only, not touching. Hence, fx has a horizontal asymptote at y equal to 4. For this graph, so we can see that as x going to the right side of x-axis, right? So it going to the positive infinity. So this function g approach but never quite reach the x-axis as x approach to infinity. So what is x-axis? When y equal to 0. We can state this behavior by the notation of limit of gx as x approach to infinity equal to 0. Thus, gx has horizontal line at y equal to 0. Let's do some example for horizontal asymptote. Determine the horizontal asymptote for these two function a and b. So for question A, fx equal to x over x minus 2. So what we want to find is the horizontal asymptote. Means that we just have to find the limits at infinity. So limit of fx as x approach to positive infinity equal to limit of x over x minus 2 as x approach to infinity. So if we just substitute the value infinity and infinity there, what we get is infinity divided with infinity. So as I have done it in the 8.1, for infinity divided by infinity, what we have to do is to divide every terms with the highest power in the denominator, with the x of highest power in the denominator. So what we need to do is divide with the highest power of the denominator. What is the highest power of the denominator? X. Okay, so everything should be divided by x. So x over x, and then x minus 2 also divided by x. So we separate these two lah. So what we get is x over x, so which is equal to 1, and then x over x equal to 1, and minus 2 over x. So 2 over x, we just left it like that because we cannot cancel anything. So just substitute the value now. So 1, 1, and then 2 divided by infinity. So what is 2 divided by infinity? It is equal to 0. Okay, we get nothing. So 1 divided by 1 equal to 1. Okay, so we get the limit of fx as x approach to infinity equal to 1. Now we need to check for the negative. So for the negative infinity, the same as the positive infinity, because we get infinity over infinity again. So we divide everything with the x with the highest power of x in the denominator. So we divide everything with x, we get limit of 1 over 1 minus 2 over x for x approach to negative infinity, which is we get 1 over 1 plus 0 again. So the result is equal to 1. Okay, means for this function, y equal to 1 is the horizontal asymptote. Okay, so for question B, limit of the function fx as x approach to infinity. The same step for question A. So what is the function? We have 2x squared minus 1 over x squared plus 1. So if we just substitute the positive infinity in the function, what we get is infinity over infinity. Means that we have to divide each term by x to the highest power of the denominator. What is the x of the to the highest power of the denominator? X squared. So we have to divide everything with x squared. So we get a limit of 2 minus 1 over x squared over 1 plus over x squared as x approach to infinity. And then we just substitute the infinity. So 1 over infinity will be 0. This one also will be 0. So 2 over 1 will be equal to 2. And then we find the limit as x approach to negative infinity. The same step for the positive infinity. We get 2 minus 1 over x squared over 1 plus over 1 over x squared as x approach to negative infinity. So 0 here and 0 here, we get 2. Thus, we get that the horizontal of this function is equal to y equal to 2. Okay, so we can conclude that y equal to 2 is the horizontal of fx. Okay, that's all for this lecture, which is subtopic 8.2. The next lecture, we are going to continue with 8.3, which is the last subtopic for chapter 8.